Welcome to the Deep Dive. Today we are diving into the world of quantum artificial intelligence, QAI, AI, and quantum computing.
Mm.
Powerful on their own, but together, really interesting.
Yeah, QAI is about using quantum computers to solve those really tough AI problems, and then using AI to make those quantum computers even better.
It could change a lot of things, how we think about intelligence, medicine, finance, and more. We're going to assume you already know a good bit about AI and quantum computing. We're going deeper than the basics today.
We're going to be looking at research, real-world examples, all the details of this field that's changing so quickly.
Let's get started. One of the cool things about QAI is using quantum computation for AI challenges. It's like having a whole new set of tools to work with for problems classical AI has struggled with.
That's right. Quantum computers can use superposition and entanglement to do things classical computers just can't. That could mean all sorts of new algorithms and AI models.
Let's talk about quantum machine learning, or QML. How is QML using quantum computers to build faster and more powerful machine learning models?
QML is a really active area of research in QAI. Right now, the focus is on hybrid quantum classical computation, using both types of computing together. One of the ways we do that is with variational quantum algorithms, VQAs. VQAs use classical computers to optimize the parameters of a quantum circuit. A quantum circuit is basically a set of operations that act on qubits. And by adjusting those parameters, we can get the quantum circuit to perform better.
So the classical computer is kind of like a guide for the quantum computer.
Exactly. A really interesting application of VQAs is in quantum neural networks, or QNNs. QNNs are quantum circuits that can learn, like neural networks in classical machine learning. But because they're based on quantum principles, they could solve problems that are way too hard for classical neural networks. Imagine a self-driving car navigating through a city. That's a lot of data. Researchers think QNNs won't be able to process all that data much faster and better than classical neural networks. That means safer self-driving cars.
So QNNs could be the brains of self-driving cars in the future.
That's what we're hoping for. And QML could change a lot of other fields, too.
Absolutely. Another area where QAI is looking really promising is in quantum planning and scheduling, QPS.
QPS is all about finding the best solution to really, really complex scheduling problems, like organizing thousands of deliveries in a city or figuring out the production flow in a huge factory. These are problems that can be too much for classical computers, but quantum algorithms might be able to handle them.
That's where you really see QAI making a difference, solving real-world problems that affect us every day.
Exactly. A great example is optimizing satellite networks. We're launching more and more satellites, and it's getting really complicated to manage them all, their positions, their communication. Quantum algorithms can help us find the best arrangement so we have good coverage and minimal interference.
Like a quantum air traffic controller for space, keeping everything organized up there.
Good analogy. And as we depend more and more on satellites, QPS is going to become even more important.
QPS has the potential to change things like logistics and telecommunications, making them more efficient and more reliable.
And it goes further than that. Manufacturing, transportation, even managing energy grids. Lots of possibilities.
Okay, now let's talk about quantum computer vision, or QCV. What's special about this field?
Quantum computer vision uses quantum mechanics to look at and analyze images in a whole new way. It's about giving AI systems quantum-enhanced vision, so they can see things with more detail and sensitivity than with classical methods.
So it's not just about seeing clearer images, it's about seeing the world through a quantum lens.
Right. QCV could change fields like robotics, surveillance, and especially medical imaging. Imagine AI that can analyze medical images incredibly accurately, spotting tiny problems that human doctors might miss. That could mean diagnosing diseases earlier and saving lives.
That's incredible.
Right.
What about the healthcare impacts?
There's a quantum image segmentation method. It was better than classical algorithms at identifying different parts of an image. This level of precision could be revolutionary for medical diagnostics, where accurate image analysis is so important.
It's like giving doctors a superpower to see things that were invisible before.
And QCV isn't just for still images. It can be used for videos, too. And motion detection. That opens up possibilities for things like self-driving cars and security systems.
It's like giving AI a whole new sense, a way to understand the world that we're only just starting to grasp.
And then we have quantum natural language processing, QNLP for short, trying to change how we interact with and understand language.
QNLP sounds huge. Just as big as QCV, we use language every day to communicate, learn, express ourselves. How could quantum computing make a difference there?
Well, the idea is to create quantum algorithms that can handle natural language, that could lead to better machine translation, sentiment analysis, maybe even AI that can really hold a conversation.
So AI that understands the subtle things about human language,
Mm,
like humor or sarcasm.
exactly. One of the key ideas in QNLP is this thing called the Categorical Distributional Compositional Model, DISCOCAT. It's a way to represent the meaning of words and phrases as quantum states. So we could go beyond just words and grammar to actually understanding the deeper meaning and the context.
Teaching AI to understand not just what we say, but what we really mean.
That's it. And being able to represent meaning this way, using quantum principles, that could lead to some really sophisticated AI. AI that can understand and even create language in a way that's way beyond what we have now.
This is fascinating. What about quantum agents and multi-agent systems, QMAS? What happens when we combine those with quantum computation?
QMAS is about creating intelligent agents that can operate in quantum environments. They'd use quantum computation for things like coordination, communication, and decision-making. Think of it like a team of AI agents working together. But with quantum powers, this could lead to really efficient systems for tackling really complex problems.
It's like collective intelligence,
Hmm.
but with a quantum boost. Can you give us a real-world example of QMAS?
Sure. Imagine self-driving cars, coordinating their movements perfectly, using quantum precision, or robots working together in a factory. Those are the kinds of things QMAS could be good at.
AI agents working together as a team, each one with its own special skills.
One interesting area within QMAS is quantum coalition formation. That's where groups of intelligent agents form alliances to reach a shared goal. Quantum algorithms can help us find the best way to form these coalitions, making sure the agents team up in the most effective way.
So AI that can strategize and negotiate, like humans do in complex systems.
That's the idea. A good example is energy management. Imagine a network of homes and businesses, all generating and using energy. Quantum algorithms could help them form coalitions to share energy in the best way, minimizing costs and being as efficient as possible.
It's like an AI-powered energy market, where agents are making the best deals for their clients, keeping the energy grid stable and sustainable.
Right. And this idea can be used in other areas too. Transportation networks, disaster relief. QMAS has huge potential to improve efficiency and coordination in all sorts of systems.
So far, we've talked about how quantum computing can help AI, but what about the other way around? How is AI being used to help develop and operate quantum computers?
That's an important part of QAI. A lot of people forget about it. AI and quantum computing help each other. AI can actually be used to solve some of the big challenges in quantum computing.
Sounds like a win-win.
It is. AI is making a big difference in quantum algorithm and experiment design. Designing quantum algorithms is hard. It takes a lot of expertise and intuition. AI, especially machine learning, can help automate and optimize that process. We might even discover new quantum algorithms, better ones.
Like having an AI assistant, working with quantum scientists to create the algorithms of the future.
Exactly. There's already some cool research happening there, like this AI system called Melvin. It actually found a new way to create and manipulate those tricky quantum states. Did it all on its own.
Wow. So AI isn't just helping researchers, it's actually starting to make discoveries in the quantum world.
Another area where AI is helping is in finding the best parameters for variational quantum algorithms. Remember those algorithms we talked about earlier? The ones that use classical computers to optimize quantum circuits. Well, finding the best parameters can take a lot of time and computing power. But AI can help speed up that process and make sure we get the best results.
Like an AI mechanic, fine-tuning that quantum computer, making sure it runs perfectly.
Yeah, that's a good way to think about it. Techniques like Gaussian process regression and graph neural networks are already doing a good job at finding those parameters.
AI is becoming super important for quantum computer scientists, helping them overcome those really tough challenges.
Another area where AI is proving its worth is in the transpilation of quantum circuits. That means converting the high-level description of a quantum algorithm into instructions that a real quantum computer can actually understand and run.
So translating from a blueprint to the language that the quantum computer speaks.
Exactly, and that's not easy, especially with the limitations of quantum computers today. AI is being used to make that translation process better, more efficient, and less likely to have errors.
Like an AI compiler, making the quantum code cleaner and more reliable.
Right. People are trying out all sorts of AI approaches, evolutionary algorithms, deep neural networks, reinforcement learning. The goal is to make quantum computing more accessible, more practical, so that researchers and developers can focus on building cool applications without getting stuck on the technical details of transpilation.
It's like we're building the tools and the infrastructure for a whole new generation of quantum software developers.
Now, one of the biggest challenges in quantum computing is error correction. Those qubits, they're so sensitive to noise and decoherence. That can mess up the information they store and cause errors in our calculations.
That sensitivity to errors seems like a big roadblock to building quantum computers that are reliable and can handle real-world tasks. How is AI helping us deal with that?
There are two ways: quantum error correction and quantum error mitigation. Quantum error correction is like fixing errors as they happen during the computation. Quantum error mitigation is more about minimizing the effects of those errors without actually fixing them.
So we fix what we can, and we minimize the impact of the ones we can't fix.
Exactly. And AI is important for both approaches. For quantum error correction, machine learning can help us create better error correction codes, more efficient and more effective. For quantum error mitigation, AI can help us figure out what kinds of errors are most likely to happen, so we can find ways to minimize their impact.
It's like having an AI quality control expert, watching the quantum computer, finding the errors, and suggesting ways to make it better.
A perfect analogy. AI is crucial for making quantum computing more reliable and more useful.
It seems like AI is really pushing the boundaries of what's possible with quantum computing.
It is, and beyond those things we just talked about, AI is also being used to improve the calibration of quantum computers. That means making sure the parameters are just right, so the computer runs at its best.
Like calibrating a really sensitive instrument, making sure it's accurate, and giving us reliable results.
Exactly. AI, especially machine learning, is making that calibration process faster and more automated. So we end up with more accurate and reliable quantum computers.
It's like an AI technician.
Yeah.
Constantly adjusting and monitoring the quantum computer, keeping it in top shape.
And what's really exciting is that AI is being used to improve the design of quantum computers themselves. Machine learning is helping us explore different qubit architectures, optimize the layout of those quantum chips, even predict how well new quantum devices will perform before we even build them.
Just like AI is the architect, designing the quantum computers of the future, making sure they're powerful and efficient.
Precisely. And this is just the beginning. As AI keeps getting better, we can expect it to have an even bigger impact on quantum computing.
It's clear that QAI has tons of potential. We've seen how it's being used to tackle big problems in machine learning, planning, computer vision, and we've seen how AI is being used to make quantum computers themselves better.
It's fascinating, these two really powerful technologies working together, pushing each other forward.
But QAI is still new, right? There are still challenges.
Of course, we're just getting started. We need to build better quantum computers, more powerful, more reliable, and we need to develop better quantum algorithms, ones that can really take advantage of what quantum computers can do.
But even with those challenges, the progress in QAI is pretty amazing, and the future looks bright. It could revolutionize so many industries and change our world in ways we can't even imagine right now.
Yeah. It's a field that needs people from different areas to work together. Physicists, computer scientists, mathematicians, engineers, all working together to push the limits.
It's like a team of superheroes, all with different superpowers, coming together to solve the biggest problems.
And as we wrap up our look at QAI, it's good to think about how far we've come. We started with the basics of AI and quantum computing, and now we've seen how they're coming together to create something totally new and exciting.
We've seen QAI being used to improve machine learning, optimize complex systems, change the game in computer vision, and even make quantum computers better.
It's a testament to how creative and smart these researchers are.
And as we look ahead, it's both amazing and humbling to think about what QAI might bring. Imagine a world with truly personalized medicine, treatments designed for your specific genes, all thanks to QAI-powered drug discovery.
Wow, it's been incredible exploring this world of QAI, seeing how these two powerful technologies are so connected. We've covered a lot, from the theory behind it all to the real-world applications, the things that are starting to happen right now.
It really is.
Yeah.
And it's changing so fast. The exciting part is we're just getting started. There's so much more to discover.
Exactly. And as we look ahead, I think it's important for the QAI community to keep sharing knowledge. Keep collaborating. Open communication and sharing ideas are crucial for innovation and progress. Absolutely. We have to break down those walls between different fields, bring together experts from all areas: physics, computer science, math, engineering, create an environment where researchers can share what they're learning, learn from each other, and work together to solve those really complex challenges ahead.
It's like building the ultimate research team, everyone bringing their own unique skills and knowledge to unlock the full potential of QAI.
And it's not just about the researchers. We have to include industry, governments, and the public, too, to make sure that QAI develops in a responsible way, an ethical way, a way that benefits everyone.
That's a really important point. Like with any powerful technology, we have to think about how QAI will impact society and make sure it's used for good. We need open and honest conversations about the potential benefits and the risks, addressing people's concerns, and working together to shape the future of QAI in a way that aligns with our values.
So, as we finish up our deep dive into QAI, let's take a minute to think about everything we've learned. We started with the basics of AI and quantum computing, and then we saw how these two fields are coming together to create something entirely new, something revolutionary.
We've seen how QAI can be used to make machine learning better, optimize complex systems, transform computer vision, even improve the way quantum computers are designed. It's amazing what these researchers are doing at the cutting edge of this field.
And as we look to the future, it's both exciting and humbling to think about what QAI might make possible. Imagine a world where personalized medicine is a reality, where treatments are tailored to your exact genes, thanks to the power of QAI in drug discovery.
Imagine cities that are truly smart, where traffic flows perfectly, energy use is optimized, resources are allocated efficiently, all thanks to QMES working in the background.
And don't forget about space exploration. QAI could revolutionize how we plan space missions, how satellites communicate, maybe even how we search for extraterrestrial life. It can process huge amounts of data, solve those super complex optimization problems.
Like giving our space agencies quantum brains, helping them explore the universe with more speed, precision, and intelligence. And who knows, maybe QAI will help us unlock the secrets of the universe itself, lead to discoveries that change our whole understanding of reality.
Those are some truly amazing possibilities. It's a future full of promise. But even as we dream about the future, we have to remember where we are now. The road ahead will be tough. It will take continued dedication, collaboration, and a commitment to doing things the right way.
Absolutely. The future of QAI isn't set in stone. It's a future that we're all creating together, through our research, our conversations, and our choices. As we wrap up this deep dive, we encourage you to keep exploring, keep asking questions, keep diving deep into this world of QAI. The journey is just beginning, and the discoveries waiting for us out there are going to be incredible.
Thanks for joining us on this exploration. Until next time, keep diving deep.